This is the relationship video in earth science. This is Mrs. Lehnert. And when we talk about relationships in earth science, we are not talking about these kinds of relationships, not people relationships. We're talking about relationships between things, like the correlation between time spent studying and your test grade. So for example, if I increase the amount of time that I spend studying, then my test grade should also increase. By the end of this video, the student will be able to state the relationship between two variables in earth science. A variable is just something that changes. So for example, in math class, you might talk about the x variable, and x could be anything that varies. So in earth science, these are things that could vary. We're going to talk about 4 different types of relationships: direct relationships, inverse relationships, cyclic, and independent. So for our first one, direct relationship, as x gets bigger, y gets bigger. Make sure you're taking notes on your notes sheet as we go through these videos. So for example, here's x. This is age on the x-axis. So as your age gets bigger, so as you get older, y, which is the height in inches, gets bigger as well. So as you get older, you get taller. This is a direct relationship. Remember, when we are talking about these axes, the x is low, the y is high. Go ahead and label that on your graph. And you should also draw this line. This line is not on your paper. You need to draw this line right now on your graph, on your paper. The second type of relationship is called an inverse relationship. Sometimes people also call this an indirect relationship. Same kind of thing. As x gets bigger, y gets smaller. Again, make sure you're writing this on your notes sheet. So x, in this case, is the time spent at the mall. So as the time spent at the mall gets bigger, so in other words, as you spend more time at the mall, y is going to get smaller. The amount of money in your pocket is going to get smaller. You're going to have less money. So again, on your sheet, you need to draw this line. Now, sometimes this line can be curved like this, or sometimes the line can be curved like this. But in either way, that line is going down from left to right, and this is an inverse relationship. Okay, let's check your understanding. The question, what type of relationship is shown in this graph? All right, hopefully you got that right. If not, just make sure you're taking your time so that you can get the rest of the questions correct. And because this is a line that goes down from left to right, remember I said that it could be curved either this way or it could be curved this way. That's why this is an inverse relationship. If that line were going up like that, then this would be a direct relationship. Here's another one to see if you get it. This is a little bit different. This is not a graph. This is a data table. What type of relationship is shown in this data table? So for this one, in order to get this, you had to think about, here's ozone destruction, right? And as you go down the chart here, these numbers are increasing, right? They're getting bigger. And if you go the same direction down the chart for the increase in ultraviolet radiation, these numbers are also increasing. They're getting bigger. So remember what we said, if this were x over here, and if this were y, as x increases, then y also increases. And so this is the same thing as a direct relationship. All right, let's try another one. For this chart, this is another data table. What type of relationship exists between the water depth and temperature for water in the summer in Lake Michigan? You may need to read this chart very carefully. Take your time, look at all of the information on here, and see if you can figure out the type of relationship between those things. So here it tells you that this is for the water in Lake Michigan, but we're looking at just the summer. So we are only looking at this data right here. We're not looking at the data for the winter, and we're only looking at the relationship between water depth, which is here. So I'm looking at this data and the temperature for the summer. So this would be like my X, and this would be my Y. So let's look at the data. As I go down the chart, these numbers are getting bigger, they're increasing. And as I go down this chart, these numbers are not getting bigger, these are getting smaller. So in this case, we're not looking at a direct relationship, we're looking at this kind of relationship, which is an inverse relationship. So hopefully you got that right. All right, so the last two types of relationship are a little bit different. This one is a cyclic relationship. In a cyclic relationship, this is a repeating pattern. And most of the relationships in earth science are cyclic. This is where the graph is going to go up and then down and then up and then down and then up and then down, and it's just going to keep on repeating that over and over again. I think about a bicycle. With a bicycle wheel just keeps going around and around and around, and it repeats itself. And so that's where that word comes from, a cyclic relationship. So make sure again that you're taking notes on your sheet. Make sure that you have drawn this line on your graph to show that this is what we tend to see in a cyclic pattern for a graph. So some examples that we tend to see, we see high and low tides. Tides are when the water goes higher and lower. If you live near a river or if you live near the ocean, you see this happening a lot. This happens with daily temperatures. So in the morning it's warm, or I'm sorry, in the morning it's cold, and in the afternoon it gets warmer, and then at night it gets cold again. So the temperature starts off low, gets higher, and then gets low, and then the next day the same thing happens again. Same thing happens with yearly temperatures. In the winter it's cold, so those temperatures are lower. In the summer it's warmer, so those temperatures are higher, and that just keeps repeating every year, lower in the winter, higher in the summer. And then phases of the moon is another example. The moon goes from full, where it's very, very bright, and then it starts to get less full, and then pretty soon it becomes full again. And so it just keeps on repeating itself. And the last and final example of a type of relationship in our science is an independent relationship. This is where X has no effect on Y at all. So in this example here, here's my age. So if you are a certain age, this would be X, then that age, your age has no effect on Y. Your age has no effect on the number of fingers that you have. So this is going to be a straight horizontal line like this. And it means that the number of, like how old you are doesn't affect the number of fingers you have, right? Doesn't matter if you're 5 or 6 or 22, you should still have 5 fingers on your hand, unless, you know, something happens. You can also have a vertical line where you might have something down here on X and Y where, again, one variable has no effect on the other variable. Again, make sure that you're taking notes on your worksheet and make sure that you're drawing this horizontal line on your worksheet. All right, let's check your understanding. What type of relationship is shown in this graph? If you said cyclic, you were right. Good job. You can see that this is going up and down and up and down, right? A repeating pattern, and so that's a cyclic pattern. These are the tides that we talked about earlier. Here's another example, another check for understanding. This time we're talking about a table. You've seen this table before, but the question is slightly different. What type of relationship exists between water depth and temperature for water in the winter in Lake Michigan? So again, we're looking at the water in Lake Michigan. We're looking at water depth. This is your X. We're looking at temperature again, which will be your Y, but this time we're looking at the winter temperatures. So this time we're looking at this column. We're not looking at our summer column. So the winter temperatures are here. That's our Y. So again, going down this chart, those temperatures are the water depth is getting bigger. But here, as we go down this chart, these are staying the same. So as x gets bigger, y stays the same. And so this should be an independent relationship. All right, so hopefully you got those right. The last thing that you need to know is how to state the relationship. So you need to know the type of relationship. That's one of the 4 different types, but sometimes we might ask you to state the relationship. So tell us what the relationship is between the different variables. So when that happens, you'll get a graph that looks like this, and we know that this would be a direct relationship, right? Because as one is increasing, the other is also increasing, but that's not usually enough to tell us really what's going on. So you would state the relationship by saying, as the number of years in school increases, the salary expectation also increases. So you should be writing that in your notes. And the way I think of this is I always look at x first. So look what's on the x-axis. And you think to yourself, okay, as this increases, the years in school. So the more years I am in school, so if I'm in school for high school and then I'm in school for longer than that, like I go to college, then the thing that is on the y-axis, the salary expectation, in other words, how much money I expect to make, that should also increase. So whenever you are asked to state the relationship, you should think to yourself, as the blank increases, right? So whatever's on the x-axis, as the blank increases, what happens to the thing that is on the y-axis? And you'll get that every time. Now you could also state this, since this is a direct relationship, you could also say the opposite. You could say as the number of years in school decreases, the salary expectation also decreases. It really doesn't matter if you say increases or decreases. I just think that it's easier to think about it in terms of as X increases, then what happens to the other thing. All right, let's check your understanding. Describe the general relationship between water depth and temperature for water in the summer in Lake Michigan. You've seen this data table before. Read the question carefully. Think about what you need to do to state the general relationship. So I'm asking you to state the relationship here. Okay, hopefully you got that right. Again, remember we're looking at water depth for X. This time we're looking in the summer. So we're looking here at the maximum for Y. And you want to say as the X, whatever the X is, as the water depth increases, because that's actually what is happening as you go down that column, what happens to the maximum temperature for the summer? And you can see here that as you go this way, that temperature is decreasing. So you should have said as the water depth increases, the average temperature in the summer decreases. Hopefully you got that right. Let's see about this one. Again, state the relationship shown in this graph. So you've seen this graph before. You should remember that this was a cyclic relationship. And so to state the relationship, you would say as the time increases, right? That's what's on the x-axis down here. So as time increases, as time goes along, the water level increases and decreases, or you could say decreases and increases, and it repeats itself. You don't want to just say it repeats itself. You want to say that it's increasing and decreasing and then increasing and decreasing. Okay, here's your last question. What 2 things did you learn from this video? I want you to describe them in detail for credit. Don't just say, I learned about graphs. Tell me, make sure that you say something specific. For example, I learned that in a direct relationship, as whatever is on the x-axis gets bigger, the object on the y-axis gets bigger as well. And please don't use the direct relationship as your example. Use something else. Hey, Obama thinks you did a great job, and so do I. Remember to bring your notes page to class, and I hope this video helped you.